All right, it looks like the number of people entering the room has slowed down, and we are right at the start of the slot. So why don't we go ahead and get started? And I'm not sure if you hit record yet, but why don't we just go ahead and do that? So thank you all so much for joining. My name is Seth Wiesman. I am a solutions architect with Ververica. And I'm really excited to be talking to you all today about Ververica platform and our recently released community edition. So you may or may not be aware, Ververica is the company founded by the original creators of Apache Flink. And along with supporting the open source community, we also offer a number of tools to help bring stream processing into production. That platform is called the Ververica platform, and we have been offering it as an enterprise solution for the past several years. Recently, just a few days ago, we announced the community edition. And so this is a completely free to use version of our platform meant to make it easy for you to get into production with Apache Flink. So to reiterate a little bit of what Konstantin mentioned in his keynote this morning, we have noticed this pattern with teams building out systems with Flink. Right, you have your one use case, and you have a very clear need to do some real-time data processing, whether it's building out a dashboard, whether it is doing model serving, whatever it may be. And you choose Flink because of its high throughputs, its strong state management guarantees, and so forth. You get that deployed to production, things go successfully, everyone's very happy. Now it's time to do it again, right? I have another use case, another team wants to do something. And you start to discover that these distributed stateful systems have very different operational needs than traditional two-tiered architectures. How do you do upgrades and rollbacks in such a way that you are consistent with your state? You're not getting bad results. How do we deploy new features in a way that makes sure that everything is done consistently and correctly? And sometimes it can just be hard, right? Distributed systems are difficult to work with. There's no way around it. And so these teams would end up going and building out these platforms and these tools to help make this easier for themselves. And the Ververica platform is our solution to this problem. It is meant to handle all of your day two operations. What I like to say is that you should be focused on your core business objective. And once you hit compile, your job is done. There's no more need to think about how you're going to run the system, scale the system, etc. And to make this tool as generally useful as possible, we wanted to make sure that we could run wherever you run. So the only requirements are Kubernetes 1.11 or later, and some sort of object storage. And so this could be S3, HDFS, an NFS drive, whatever you're working with, we probably support it out of the box. And we also support all of the major cloud vendors and Kubernetes distributions out of the box. So it should be incredibly simple for you to just get started and get the platform deployed so that you can run your applications in production. Before I get to the next piece, actually, let's go here. So at the core of what we do with our platform is try and raise the abstraction level, right? State is the thing that makes Flink so powerful, but it is also what can make it difficult to reason about in production, right? As soon as things become stateful, there's a lot more that could potentially go wrong if you're not sure what you're doing when it comes to an operations POV. And when you write your Flink code and you deploy, you're just working with Apache Flink on Yarn or wherever else, you deploy a job. And a job is your code at a particular point in time with a specific configuration and initial state. And then you deploy a new feature, right? Product manager came and said, this looks really great. I want to improve it. And so we need to deploy something else. And this is a new job, even though it is part of the same service, right? It's a continuation. And so we want to be able to reason about these as one consistent single object. I need to carry my state over. I need to carry my configurations over and so forth. Now I want to rescale, right? I haven't changed my code, but that's a change in configuration. Again, that is a new Flink job. And I need to do a rollback. So, something went wrong. Mistakes happen. We pushed a bug to production. I need to roll my code back. I also want to roll back my state because I want to make sure that I have consistent, correct results. What we look to do is raise the abstraction level. So instead of working with jobs, we're working with applications. These are long-lived services that keep track of your code, state, and configuration over time so that we can have this long-lived service that evolves and changes as we do, and that can be consistently upgraded, rolled back, and even forked. Same way that you can fork a repository on GitHub, you can fork an application, right? Create an identical copy, same code, same internal state, same configurations. But now I'm going to make one change. So maybe it is deploy my new version or try out this configuration change. It gives us a really powerful way of doing blue-green deployments such that we can be incredibly confident that our changes are correct, right? It's the same code and same state. If I can deploy here correctly, I know it's going to work in production. And it is incredibly easy to get started. So to run the Community Edition or the Enterprise Edition, it is a simple Helm chart. So Helm install the Ververica platform on any Kubernetes cluster, and you are good to go. So for really the rest of this talk, I'm going to be walking through the platform, talking about how to use it, how it solves common and not so common operational challenges. And I would love to make this as interactive as possible. So if you have questions as we go through, please post them in the chat. I'm happy to look at them. So I will go ahead and start sharing my screen. So we are inside the Ververica platform, and I am running the Community Edition. As we mentioned, the Community Edition is free to use. It has no arbitrary restrictions on your deployments. That means we can run any number of Flink applications, and we can run them at any parallelism we like. So we are not going to restrict your usage of this platform. I am running on top of a Kubernetes cluster that I have installed, and I also have MinIO set up, which is an S3 compatible object store that I'm going to use for all of my blob storage. So let's go ahead and deploy something. Earlier, Konstantin was using the top speed windowing application that ships with Flink. I wanted to do something a little more interesting. And so we built this job that is Flink repository analytics. So Apache Flink is a massive, massive project. I believe at this point it's spread out across 8 different repositories. There are hundreds of active contributors to the framework. And so we wrote this job that pulls commits from GitHub's API and computes the number of changes happening across different modules within the project over time. So we can see, for instance, that there's a lot of activity happening in the table API, right? SQL is something we're taking a lot of care to improve right now, where something like the Yarn integration is fairly stable, right? We've supported Yarn as a resource manager for many years now, and while there are bug fixes and improvements, there are not major changes happening there day to day. So we need to go ahead and upload this artifact. And I've already done that, mostly because I want to make sure that my computer could handle streaming this video along with uploading a jar that does exactly what we're discussing. The question is, where does this jar live, right? Where did I actually upload it to? We said that Flink requires blob storage, right? If you've used it in the past, you know you need somewhere to write out your checkpoints and your save points. If you're using an HA service for high availability, that also requires some blob storage. The platform also uses blob storage. So that is where we're going to put this jar. When you install the platform, this is the one step that I did not show today, you specify what we call universal blob storage. And this will be the central blob storage used for all the platform's needs. It's where we are going to upload your user code jars. It is also where we are going to pre-configure your deployments for their checkpoint, save points, and HA directories. We know that this is something that you need configured on every job, so why should you have to do it yourself? You can, of course, override this on any particular deployment. So if I want my job to write out its checkpoints somewhere else for whatever reason, I am absolutely free to do that. So let's go back and we will create our first deployments. I'm going to go ahead and call this Flink Repo Analytics. And now I need my deployment target. My deployment target corresponds to a Kubernetes namespace. So where do I actually want to run this code, run this application? And I have one preset up. And I'm going to pick out my jar. And this is it, right? I'm also going to specify my main entry class because I did not put that in my POM. But this is everything that I need to do. There are other tabs that give us access to more knobs under the hood that we are going to take a look at. But for most of your day-to-day workflows, this is the page you're going to be working with. We work very hard to give you sensible defaults out of the box. So let's go ahead and create this deployment. And it is going to start running. And so the platform, as you can see, is taking me through the full lifecycle of creating my job, spinning up the cluster, right? I need to allocate pods and then get the job running. While that is occurring, we can take a look at the main overview page. So this gives us all the high-level information we need about our deployments. We can see that it is a stateful job, right? This is Flink, and so state is incredibly important. We want to make sure that any change we make takes that into account. I can look at how I have scaled my job manager and task managers, any logging or configurations. You can see that I'm using the file system state backend, although we didn't explicitly specify that. It was listed somewhere else that, again, we'll look at momentarily, along with a Prometheus reporter. So this is like my centralized metric system that our organization uses, along with basic information about our artifact. So the job is now up and running. We can see it has moved to its current state. We have access to the job graph. So this is something that people really like to look at in the Flink UI. And we give you a little extra information. So I have checkpoints running in the background, and we can actually see the number of, the number of records flowing between each operator and the state size in our operator. So we know that as each checkpoint occurs, currently I have just a few bytes in my source and a few kilobytes within my window. There's the job events tab. This tells us what the platform is actually doing under the hood. So in any scenario where you need to do some troubleshooting, something doesn't work for whatever reason, this can tell you what the platform is attempting to do. And you may see errors such as, I do not have the right permissions to deploy to that Kubernetes namespace, or other such potential issues. And the jobs tab. So while we raise the abstraction level, right, we are not focusing on jobs anymore. It is still something that Flink exposes, and it would be disingenuous to pretend that individual jobs do not exist. And so this shows us all the jobs that make up our deployments over time. Currently, I only have the one because it is all that I'm using. But as we make changes, we're going to see this screen populate, excuse me. And finally, we have our snapshots tab. So these are all of the retained checkpoints and save points that the platform is aware of, so that we can always go back to a previous point within our application. The Flink UI is available if we would like to go in there and take a look, but there's really no need to ever go in here. Our intent is to expose all the information you need within the platform. And so finally, I want to go ahead and take a look at my metrics. I am running Prometheus and Grafana in the background, and it is collecting all of the metrics for my deployment. So I can see things like checkpoint size and throughputs, number of checkpoints, the amount of memory being used by my task managers, the basics that you would need for any successful Flink deployment, things that you want to monitor. Of course, you are going to have job-specific metrics on top of this, but these are some of the good ones to take a look at on any Flink deployments. One of the things that's really key here is that I said deployment and not job. And so as we make changes, if we go back here, you'll see there's a deployment ID. This is different than my job ID, right? Flink has a job ID. We give you deployment IDs. And with this, we're able to scope your metrics and logs under a single deployment so that you can see how things respond as you make changes over time. When I make a change here that results in a new Flink job, I am going to get them sent to the same place in my metric system. So I can see how those things affected each other. I do not have logging set up in this configuration, but it would do the same thing. I would ensure that I would see all the logs for my application in one centralized place, regardless of how many Flink jobs there are running under the hood. So let me switch over to this question. I know there are two types of deployments. One, Flink apps run on a backend Flink cluster, Kubernetes namespace, and two, Dockerized Flink apps with its runtime infra included. How to differentiate these two from a deployment point of view? So when working with the Ververica platform, we do not expose any of this, right? So those are low-level details that we don't want you to have to worry about. I will tell you what is that you do get a single Flink cluster per deployment. So if we go back here, you can see that I have one deployment running. If I create another, right? So let's say that I went in and created a new deployment because I now have the second application I want to run. That would run on its own Flink cluster, deployed on Kubernetes. So same Kubernetes under the hood, but two different Flink clusters, right? So we're not sharing task managers, we're not sharing job managers. That is really important for streaming workloads because these are long-lived services. And so we want to be able to scale the cluster to exactly what your application needs. We also want to be able to tune the configurations to exactly what your application needs. If I can get a 5% performance improvement on this very specific application by tuning one config that may be detrimental to others, you want to take that because over months and months, this is a long-lived, continuously running service, that is going to add up to a very large performance benefit. So that is not, these differences are not going to be exposed. You simply say, run my job, and we're going to make that happen. So let's go back in here and let's make a change. I want to, maybe I'm deploying a new version of my code. I don't have a second jar here today, but maybe I wanted to deploy a new feature. So instead, I'm going to scale up because fundamentally that is the same thing from Flink's point of view, right? We are creating a new Flink job. It is a continuation of our deployment. And we're going to do all of this very declaratively. So I'm going to make this change and save it. And we'll see in just a moment, this will move to transitioning. So we now know that we need to make a change. We need to allocate more resources, redistribute our state, and get our job running again from its latest position. If you look under the Events tab, you'll see what's happening, right? We are making a stateful upgrade. Flink is taking a save point and making changes to the cluster. We can now see the save point that was taken. So this lives here under our snapshot deployment. And our checkpoints went away because that job is gone. We don't need those anymore. When this is finished, so we're waiting on some hardware resources to become available, the job will continue running from its latest state as if nothing had ever occurred. So there we go. So now our job has been upgraded, right? It is running again. And I actually have the parallelism for one of these components operators pinned down, so you can see that the job graph changed just to show that something did occur. And if we go under the jobs tab, we can now see that here was this past job. Let's go back to metrics for just a moment. We can now see that these tabs, right, this memory usage is all showing up on a single graph. So I can now connect these two. There's a little bit of downtime as the application was changing, but I have a unified view of how this change affected task manager memory. If for whatever reason I wanted to see the metrics or logs for one very specific job, I can do that. So I can go here and we will drill down to just that one job. It's getting cut off because time is moving forward, but this job is no longer running. But you can get the idea. So let's make a slightly bigger change, right? We've been looking at this standard tab, but Flink provides a lot of knobs out of the box. And we do not want to hide those from you, right? We're not pretending that there's such thing as a one-size-fits-all solution, but that most organizations find that most of their deployments look very similar once they find what works for them. So under the Advanced tab, you have access to everything that you would have access to with a standard Flink deployment. We can set things like upgrade strategies, excuse me. So this is Flink. You want your job to be stateful. If for whatever reason you were doing something that was completely stateless, you can specify that here, and your upgrades will be a little faster because the platform is not going to take the time to make snapshots under the hood. We also need a restore strategy. So when I start a new job, when I make a change that results in my deployment changing, what state do I want to use? Could be none. Sometimes this is important, right? I just want to throw everything, my state away and start over. It could be the latest save point. So what is the most recent save point that my system has taken? And when you trigger an upgrade manually, so change the parallelism, deploy new code, the platform will take a save point automatically. Or we can use latest state. So use either the latest save point or the latest retained checkpoint if one is newer than the last save point. And this is really what you want to be using in production, right? 9 times out of 10, 99 times out of 100 even, you want to be using the most up-to-date state for your application, regardless of where it came from. There's a reason these two are separate, and we'll talk about that in just a moment. We have access to our Flink version. So Ververica supports every Flink version for 3 years. SLA covered support, and this includes off-cycle bug fixes if you find something inside of Flink that is causing you issue. So we can choose which version we would like to run. We can also choose different tags. So I'm running Scala 2.12, maybe I want to be running Scala 2.11. Finally, we need to think about high availability. So when you are running a distributed system, one of the most difficult challenges is making sure that it is always available. With Flink, there are a lot of things that we do to make that work. So you have your task managers that may go down, and the job manager will try and bring them back online. But then you need your job manager to be highly available. And with Apache Flink, that requires running Zookeeper, which can be a challenging piece of software to run successfully in production. That is why the Ververica platform comes with a Kubernetes-based HA. That means that you do not need to run Zookeeper. You're going to get high availability out of the box without any other components. You really, truly only need Kubernetes and Object Store to deploy Flink successfully to production when running on top of this platform. The reason why we have latest state and latest save points is that with Kubernetes HA, we can support all of these new features because we have extra insight into what your job is really doing under the hood. If you choose to use Zookeeper for whatever reason, you must use latest save points. We also want to make sure that things are secure. So we are running in enterprises. We have regulatory requirements to meet. SSL is very important. And so with one click, we can have SSL enabled for our deployments. This encrypts all the communication happening between task managers. So as data is being shipped around my job graph, things are going to change. They will be encrypted. It also encrypts all of the communication between the platform and the job manager itself. So under the hood, the Ververica platform is working with the Flink clients, and we're going to encrypt that communication. When you use SSL with Apache Flink, when you configure that yourself, you are using Java-based SSL. With Ververica platform, we ship OpenSSL, and we have found this to be over 200% more performance than Java. So immediately you're getting serious performance boosts, and we're not paying much of a cost to enable this change. And finally, I have my configurations. So, this is where I specified I want to use the file system state backend. I'm using a Prometheus reporter. Let's say that I wanted to change my checkpoint directory. I could go ahead and do that here. It will give me a warning that I'm overwriting my pre-configured blob storage, but maybe that's okay. Anything else that you're familiar with from the Flink conf or the configuration page on Apache Flink, on Apache Flink's websites, you can configure here. We have low-level control over our pods. So maybe I want to configure more memory for my job manager. I want a certain number of CPUs on my task manager, etc. That is all available for us to configure. And logging templates. So logging is incredibly important in production. You need to know what you're doing. So we can set all of our log levels. We can even set a custom log4j template. So exactly what you want to print out in the format that you want it, it's supported. So this is a standard logger. Maybe I want all of my logging to come out in JSON. I could create a custom template that allowed me to do that. The question about how the enterprise and community editions differ, I will get to that at the end of this talk. That is the last few slides in my slide deck. Everything that I am discussing right now is the community edition though. So that is what we are demoing at this moment. So that's great. But we see that a lot of these changes, a lot of those configurations are stable. For instance, maybe I need everything to run with OpenSSL, right? Or SSL in general. Or I want all of my deployments to use Prometheus because we have a centralized Prometheus installation that our organization uses. That is why we ship with deployment defaults. So this is the same page that we were looking at before, but allows us to set basic defaults. So this is where I actually went in and said, use the file system as my state backend, use Prometheus. We could go and say that every job out of the box needs SSL enabled, and I want every job to have Kubernetes HA, right? This is important to me. I just want everyone to do this. And now this is why we can say, set this up once, create our defaults, right? We as a platform team running the community edition know what we like, and our developers can go in and create a very simple deployment. Just say, here's my code, here's my parallelism, make it all work for me. So let's go in and take a look at a failure case. Perhaps something went wrong, right? So I made that change to my code a little while ago. We scaled up, but maybe it was we released a new feature. And it turns out something went wrong. I released a bug into production. It happens, right? Things, we try to test our code, but unfortunately, things go wrong. And in particular, this is a very tricky bug with Flink because it is one where I am improperly parsing my input data. So I'm pulling these JSON messages from GitHub, and for whatever reason, there is an edge case that I miss, and it throws an exception, which causes Flink to restart the job from its last checkpoint, which is exactly what it's supposed to do. Except I am running with exactly once semantics, which means the job fails. It pulls that same data from the API, and it fails again, and I'm stuck in a restart loop. And I cannot suspend my job because when you're in a restart loop, triggering a save point typically is not going to work unless you can time it just right. But I have externalized checkpoints enabled, right? We can see that this job, since I started, has taken 105 checkpoints. One of them is the most recent. It's the checkpoint that occurred just before we hit this failure loop. And even though I can't take a save point, I can simply cancel the job. So that's what I'm going to do. And because I have retained checkpoints enabled, this checkpoint is going to be maintained. And now, when I go ahead and do my next deployment, it is what will be shipped and used as my initial state for my application. So I did that, right? I've canceled my job. We fixed it, right? At least we're not having any issues. So maybe we go in and we're going to set our jar back to what it was at before, right? So we're going to roll back to the previous version of our code. In this case, just so I can make a change, I'm going to re-lower my parallelism. And then I can take this latest checkpoint and reset it to this snapshot. So now I have started, I can restart this application, and I am starting from my latest state with my old version of the code. This means that we are not going to lose any data, and we're not going to output any bad results. We have rolled things back in such a way that we maintain consistency within the system. Let me check the time. So we are at 10. Okay. So just a few more things. I've been showing you this lovely UI. It's meant to be used, right? We encourage you to use it. It's meant to be easy to take advantage of. But we also acknowledge that a lot of organizations like CI/CD pipelines, right? I like to go in and build some extra tooling, perhaps. And that is why we ship with a full Swagger spec for our REST API. There is absolutely nothing that I just showed you that cannot be done through the REST API. There's no special business logic within the platform itself. And so if you want to go ahead and script all of this, you want to make sure that every time you merge into master, you automatically deploy your application, you can do that. It is supported. It is a public part of our API. And so that is it, right? That is a high-level overview of Ververica platform. I'm going to go ahead and stop sharing and go through the last little bit. So, excuse me. So let me open up these slides again. Okay. So I see there are a few more questions. I'm going to get through the last couple slides as a wrap up, and then I will get to those. So we have different editions of this platform. There's a community edition that is available for production use. Everyone is free to use it. Download it today, deploy it to production, you're good to go. If you are interested in the enterprise edition, and I will touch on the extra features that it provides in just a moment, but you are not yet in production, you're not ready to commit to a full enterprise license, we do offer a development license. And so this gets you the full platform along with support at a significantly reduced rate for the duration that you are not in production. We have a startup license. So if you are a startup, fewer than 50 employees, and interested in doing some co-branding marketing with us, you get full access to the platform, again, at a significantly reduced rate. So all the enterprise editions, features and support. And then there is the standard enterprise license. And so if you are someone that needs to make sure that in the case of emergency, I can get someone on the phone in 10 minutes, this is for you. And it gives you all the features of the platform, everything that you could need to run successfully. So as it sits today, yes, I can talk about the fourth feature in just a moment. As it sits today, the Community Edition gives you access to all of the operational features within Ververica platform. So application management lifecycle, configuration and metadata management, artifact management, and Kubernetes-based Flink failover. The Enterprise Edition gives you all of that along with long-term SLA support, enterprise-ready authentication authorization, so we can have users with permissions, we can have API tokens, etc. It ships with cross-data center failover. So in the case of emergency, we've been talking a lot about being highly available. If you lose an entire data center, right, your entire Kubernetes cluster goes away, that whole building is gone, we can restart your Flink jobs in another data center on the other side of the earth. So the highest level of availability you could possibly achieve, and full multi-tenancy support. So if you have multiple teams running on top of a Ververica platform, they can have their own place within each that does not overlap with each other. That long-term SLA support does come with 3-year support for each Flink release, which means off-cycle bug fixes. If you find something in Flink that is causing you issues in production today, we can get you a fix out the door immediately, where the open source community only releases roughly every 3 months, and not everything is prioritized for every release. We do vulnerability and security checks and fixes. So for instance, Flink uses Jackson as a dependency. It is regularly flagged with security vulnerabilities. We will upgrade the version and ship you a new release. And migration support. So even though we support Flink 1.8 for the next 3 years, maybe you want to move to 1.10 and you have some questions, we can help you there. You also get access to the Ververica and Alibaba Flink engineering team. So a large majority of the active Flink committers and PMC members are employed by either Ververica or Alibaba. And if you have a question, right, this isn't a production issue, but just I've got this question about the table API and whether or not I should use feature A or feature B, which one would be better in this situation. We can give you access to the people that work on the table API day in and day out, and that can give you the best answer to that question. Think about it as an SLA covered version of the Flink mailing list. And for support, right, there are different levels that you can choose from depending on how quickly you require responses. So thank you. I do see there's some questions, so I'll get to them now. I hope I sufficiently answered the question of the difference between enterprise and community editions. The autopilot feature that Constantine mentioned will be part of the enterprise edition soon enough. When I go back to the Flink UI and show the fork feature, yes, so let me reshare my screen for just a moment. So I'm sharing my screen. So I have this running, right? So I have my code, it's still running. I just did a rollback, right? And that was important because that was the last thing I demoed, because there was a bug in production. And the question is, how should we have actually tested that? Because maybe it was a bug that, right, I didn't even think of, right? Parsing error is not something that you could maybe think of ahead of time, right? You need to actually deploy it with real production data to see that there's an edge case that you're missing. So instead of simply upgrading my code, my deployment, I'm going to fork my deployment. And so I'm going to hit fork. And I have now created a fork of Flink repo analytics. And what this did was create an identical copy. So you now see there are 2 deployments. It has the exact same code, the exact same configurations as my other deployments. It also has, it's not showing on the snapshots tab, but it does also use the same state. So when I forked my job, I took a save point of the initial deployment. So I have access to exactly what production looks like. This is identical in every way, shape, or form. My job is currently canceled, it's not running. So now would be a time to make a change, right? I can update my code, I can change my parallelism. Maybe I'm writing out to a database and I'm going to change one of my arguments so that I am reading production data, but I'm writing out to a QA database, right? So I don't want to mess with production in any way. We'll make those changes, we will save them. I can now run this deployment as any other. It's going to be identical in every way, shape, and form to what I just had in production, except the very explicit changes that I made. This gives us a foolproof way of doing blue-green deployments. Because this is identical to production, and if the change I made succeeds here, it is guaranteed to be correct, right? There's no difference. There's no way that my environment is different than production's environment. They are identical in every way, shape, or form. And so it gives us a really easy way to deploy confidently. Let me stop sharing again. Are there a way to version or control the application definition? So yes and no, not directly in the platform, but let me go back to sharing for just a moment. So when we looked at configuring our deployments, I showed you standard, I showed you advanced. There's also YAML. So when you use the REST API, you post a YAML definition of what you want your application to look like. Typically, and this is very common for our users, right, is that they have the UI, they like to be able to look in here as a way to monitor what's going on, but they have a CI/CD pipeline for production so that every time they merge to master, every time they cut a release, it is automatically deployed. This YAML file, you can version within your repository. So what happens is inside of your, let's say, Git repo where you are maintaining your Flink job, you will have a vvp.yaml file that has the specification for your deployment. And that is what is versioned. And so now you can have a hook inside of Travis or Circle CI or whatever you're using that says every time something gets merged into master, go ahead and deploy using the YAML file. And so that is versioned, and then to roll something back, you simply commit it, you pull the last version from that YAML file and you commit that to master as a rollback and so forth. I hope that sufficiently answered your question. I believe we have a few more minutes, so I'm happy to stick around if other people have questions. Again, Community Edition, free to use, free to download, free to use in production. No arbitrary limitations on number of deployments, size of your deployments. It's really just meant to make Flink as easy to use in production as possible. So I'm going to go ahead and just stick here for the next few minutes, but in case anyone else has any other questions. But otherwise, thank you all so much for joining today and helping to make this virtual Flink forward a success.